General Class Question Pool. Questions and correct answers only July 1, 2019 to June 30, 2023. By KATB. Last edited March 8, 2019. Subelement G5 Electrical Principles, 3 exam questions, 3 groups. G5A Reactance, Inductance, Capacitance, Impedance, Impedance Matching. What is impedance? Answer: the opposition to the flow of current in an AC circuit. What is reactance? Answer: opposition to the flow of alternating current caused by capacitance or inductance. Which of the following causes opposition to the flow of alternating current in an inductor? Answer: reactance. Which of the following causes opposition to the flow of alternating current in a capacitor? Answer: reactance. How does an inductor react to AC? Answer: as the frequency of the applied AC increases, the reactance increases. How does a capacitor react to AC? Answer: as the frequency of the applied AC increases, the reactance decreases. What happens when the impedance of an electrical load is equal to the output impedance of a power source, assuming both impedances are resistive? Answer: the source can deliver maximum power to the load. What is one reason to use an impedance matching transformer? Answer: to maximize the transfer of power. What unit is used to measure reactance? Answer: ohm. Which of the following devices can be used for impedance matching at radio frequencies? Answer: all these choices are correct. A transformer. A pi network. A length of transmission line. Which of the following describes one method of impedance matching between two AC circuits? Answer: insert an LC network between the two circuits. G5B the decibel, current and voltage dividers, electrical power calculations, sine wave root mean square, RMS values, PEP calculations. What dB change represents a factor of 2 increase or decrease in power? Answer: approximately 3 dB. How does the total current relate to the individual currents in each branch of a purely resistive parallel circuit? Answer: it equals the sum of the currents through each branch. How many watts of electrical power are used if 400 VDC is supplied to an 800 ohm load? Answer: 200 watts. How many watts of electrical power are used by a 12 VDC light bulb that draws 0.2 amperes? Answer: 2.4 watts. How many watts are dissipated when a current of 7.0 milliamperes flows through a 1250 ohm resistance? Answer: approximately 61 milliwatts. What is the output PEP from a transmitter if an oscilloscope measures 200 volts peak-to-peak across a 50 ohm dummy load connected to the transmitter output? Answer: 100 watts. What value of an AC signal produces the same power dissipation in a resistor as a DC voltage of the same value? Answer: the RMS value. What is the peak-to-peak voltage of a sine wave with an RMS voltage of 120.0 volts? Answer: 339.4 volts. What is the RMS voltage of a sine wave with a value of 17 volts peak? Answer: 12 volts. What percentage of power loss would result from a transmission line loss of 1 dB? Answer: 20.6%. What is the ratio of peak envelope power to average power for an unmodulated carrier? Answer: 1.00. What would be the RMS voltage across a 50 ohm dummy load dissipating 1200 watts? Answer: 245 volts. What is the output PEP of an unmodulated carrier if an average reading wattmeter connected to the transmitter output indicates 1060 watts? Answer: 1060 watts. What is the output PEP from a transmitter if an oscilloscope measures 500 volts peak-to-peak across a 50 ohm resistive load connected to the transmitter output? Answer: 625 watts. G5C resistors, capacitors, and inductors in series and parallel, transformers. What causes a voltage to appear across the secondary winding of a transformer when an AC voltage source is connected across its primary winding? Answer, mutual inductance. What happens if a signal is applied to the secondary winding of a 4:1 voltage step-down transformer instead of the primary winding? Answer, the output voltage is multiplied by 4. Which of the following components increases the total resistance of a resistor? Answer, a series resistor. What is the total resistance of three 100 ohm resistors in parallel? Answer, 33.3 ohms. If three equal value resistors in series produce 450 ohms, what is the value of each resistor? Answer, 150 ohms. What is the RMS voltage across a 500-turn secondary winding in a transformer if the 2250-turn primary is connected to 120 VAC? Answer, 26.7 volts. What is the turns ratio of a transformer used to match an audio amplifier having 600 ohm output impedance to a speaker having 4 ohm impedance? Answer, 12.2 to 1. What is the equivalent capacitance of two 5.0 nanofarad capacitors and one 750 picofarad capacitor connected in parallel? Answer, 10.750 nanofarads. What is the capacitance of three 100 microfarad capacitors connected in series? Answer, 33.3 microfarads. What is the inductance of three 10 millihenry inductors connected in parallel? Answer, 3.3 millihenries. What is the inductance of a 20 millihenry inductor connected in series with a 50 millihenry inductor? Answer, 70 millihenries. What is the capacitance of a 20 microfarad capacitor connected in series with a 50 microfarad capacitor? Answer, 14.3 microfarads. Which of the following components should be added to a capacitor to increase the capacitance? Answer, a capacitor in parallel. Which of the following components should be added to an inductor to increase the inductance? Answer, an inductor in series. What is the total resistance of a 10 ohm, a 20 ohm, and a 50 ohm resistor connected in parallel? Answer, 5.9 ohms. Why is the conductor of the primary winding of many voltage step-up transformers larger in diameter than the conductor of the secondary winding? Answer, to accommodate the higher current of the primary. What is the value in nanofarads, NF, of a 22,000 picofarad, PF, capacitor? Answer, 22. What is the value in microfarads of a 4,700 nanofarad, NF, capacitor? Answer, 4.7.